Good morning, grade 8. We will now start. We're jumping now to our next topic, which
Mhm.
is properties of matter. Please turn on your camera. Please turn on your camera. I'll be sharing my screen. Let me share my screen. Can you see my shared screen now?
Yes, sure.
Okay,
Yes, sir.
right? So, properties of matter. What really underlies
Wait, Mister.
species
Oh, there. Never mind, sir.
and what are the states of matter? States of matter. As we all know, solid, liquid, gas. Supposed to be it's five, five states of matter, but we will be focusing on the three states of matter since um, we are dealing with it at home, we're dealing with it everywhere. Aside from that, the other fourth state and the fifth state is um, under observation, and in under also some laboratories they tend to have experiments with this. We'll be waiting for the results for it to be published. Okay. The fourth state of matter is the plasma, and the fifth state of matter is the Bose-Einstein condensate. Anyway, let's focus on the three states of matter. Gas. Let's start with gas. Do you agree with the statement we live in the ocean of gases? Do you agree with me? We are living in the ocean of gases. Actually, it's true. The gas
We're
refers
living under the ocean, sir.
ocean of gases. We are actually living with gases. Okay.
Yes, under the ocean of gas, sir.
The gases referred to is the atmosphere. Okay, the atmosphere is a thin veil between us and the outer space. Atmospheric gases support life on Earth, correct? Earth's atmosphere consists mainly of nitrogen, which is 78%, oxygen, which is 21%, and the other gases like carbon dioxide, water vapor, argon, helium, xenon, neon, and krypton. A gas exhibits the following characteristic. Please take note. It has no definite shape and volume. Yes, it diffuses easily. It can diffuse easily. It flows, correct? It can be compressed. It exerts pressure. Again, the gas exhibits the following characteristics or properties. It has no definite shape and volume, number one. Number two, it diffuses easily. Number three, it flows. Number four, it can be compressed. And number five, it exerts pressure. The characteristic behavior of gases can be explained by the kinetic molecular theory of matter, or the KMT. Okay, the term kinetic means motion, so moving. Okay, according to KMT, gas particles are considered to be very small, have negligible volume, and are far apart from each other. A gas is most empty space, or mostly an empty space. There is a negligible attractive force existing between gas particles. This attractive force is called intermolecular force. The gas particles are at constant and chaotic motion. These moving particles may be atoms or molecules. A molecule is a group of two or more atoms held together by a chemical force. Again, according to kinetic molecular theory of matter, that gas particles are considered to be very small and have invisible volume, and they're moving. Okay, they're mostly in empty space, and there are attractive forces existing between gas particles. That is why they're moving. That is why they can be compressed, and that is why they're exerting more force. I'm sorry for the connection problem. Are you still with me? Grade 8? Are you still with me? Robbie?
Yes, sir.
Okay, so let's continue. Another assumption of the kinetic theory is that the average kinetic energy of molecular or molecules is proportional to its absolute temperature. Okay? This means that,
Excuse me. Okay. Never mind, sir.
yes, Robbie. Robbie?
Never mind, sir. When you started talking, your screen wasn't shared for me, but now it is.
Okay. This means that as temperature goes higher, the molecules move faster. So that is actually um, the proportion. No? The higher the temperature, the faster the movement of molecules. As the temperature goes lower, the molecules move slower. So again, the higher the temperature, the faster the movement of molecules. The lower the temperature, the slower the movement of molecules. Diffusion. Okay? Diffusion in gases. Since very negligible intermolecular force exists between its molecules, gases fill their container regardless of their shape and volume, and contained gas diffuses into every available space. This explains why you can smell adobo throughout the kitchen. This also explains why gases do not have definite shape and volume. Okay? When someone is cooking in your kitchen, you can actually smell the fragrance of the food simply because gas actually diffuse easily. That is actually diffusion. It mixes with the other gases, and you can feel or you can smell the fragrance of that particular food. Okay, please read, Rabbi.
Gas molecules are very far from one another. Between the molecules are empty spaces. This explains why gases may be compressed.
Correct. Huh? Because molecules are very far from one another, or gas molecules are very far from one another, there are some empty spaces between those molecules. Okay. One way to check on the compression with gases is to your tire. Have you observed your car tire? Those are compression. Those are gas compression. Okay. If you're going to observe, they tend to put a lot of air inside the tire and compress the air, making the tire what? Harder. Let's move forward. Any questions so far? Questions?
No, sir.
None, sir.
Okay. Pressure. Pressure is defined as force exerted per unit area. Okay. Gas pressure is the result of simultaneous collision of gas molecules with one another with an object. Barometer is an instrument to measure the atmospheric pressure. A falling barometer signifies decreasing air pressure, and a rising barometer signifies increasing air pressure. Okay? When can you observe that there are some gas pressures? The low pressure and the high pressure. Okay? Barometer measures the atmospheric pressure. If there is a low pressure, therefore, there are some depressions happening or a coming typhoon. Okay? If there are some high pressure, therefore, there's some a lot of air actually moving on the side or actually moving in the environment. So tendency is you can actually experience pressure anywhere. Okay, air pressure, and even in your tire, no, when you compress your tire, you also putting pressure on them because they're actually have a collision, no, simultaneous collision, making pressure more, um, making pressure actually intact in the tire. Liquids. Let's move now to liquids. Ability to flow. Like gases, liquids are referred to as fluids. A liquid may be poured from one container to another. Weak attractive forces hold the liquid molecules yet allow them to move and side past one another. This explains why liquids have no definite shape. Okay, liquids also have no definite shape. And liquid also allows movement from one another. Okay, slide past one another and have weaker attractive forces. Okay, viscosity. Are you familiar with viscosity? Viscosity.
Yes,
Have you
teacher.
heard about
I think
viscosity?
it's the thickness of a liquid.
Correct. It's the thickness of the liquid. Correct. It is actually lapot ba lapot. In Bisaya, it's lapot. Okay, that's viscous lapot. Just like your syrup. What else? Um, your honey. That is actually viscosity. Viscous. Okay. This is the resistance to flow. If you're going to pour that one, it actually resists flowing because it is actually in viscous state. Diffusion in liquid. The particles of liquid move around each other. This characteristic is responsible for diffusion in liquid. Okay? Diffusion in liquid, you can actually observe that one anywhere, even in your kitchen. Okay? Even in water. Remember that your water is a universal solvent. Okay? When you say universal solvent, it can dissolve actually many substances and many elements, and it is actually used anywhere, even in cleaning, because water, H2O, is a universal solvent. Aside from that, water also is one of the products. If there are some chemical reactions, there's always water as a byproduct. Surface tension. Water has surface tension. Please read EM.
Surface tension is defined as the force on the surface of a liquid that makes the surface area as small as possible. Surface tension allows needles, paper clips, and razor blades to float on water if placed carefully on the surface. It also explains why drops of water are spherical in shape.
Okay. Surface tension. This is allows needles, paper clips. Have you seen this one? And razor blades to float. Remember that these are iron. Okay. If placed carefully on surface, it also explains why drop of waters are spherical in shape. If you're going to observe, if you're really observant with the nature, me as a child before, I usually observe that one. Or I usually go outside and check on the water vapor on some leaves and, you know, thinking about how these are actually formed. That is actually the power of surface tension. Okay? Just like when you put a needle in water, have you tried this one? Putting a needle in the water, grade 8. Have you tried that one?
No, sir, but I tried putting a diffuser, sir.
Putting what, Rabi? You tried putting?
A deeper.
Okay. So that is actually the power of surface tension. There is really pressure in water. Okay. And aside from that, these are used by some insects also to float on water. Okay. That is because of surface tension. Question so far with surface
No,
tension.
sir.
No, sure.
Okay. This is allows some insects to float. That is actually because of surface tension. Can you still see my shared screen?
Yes, sir.
Okay. Capillary action. Please read, Rabi.
Yes, sir.
Rabi.
Capillary action results from the competition between cohesive forces, intermolecular forces within the liquid, and adhesive forces, forces between different substances like water and glass. The relative strengths of the adhesive forces and cohesive forces explain why some meniscus may curve up like in water or curve down like in mercury. Meniscus is the convex or concave surface of a column of liquid. Capillary action also explains the absorbing property of paper towel and cotton.
Okay. Have you tried experimenting with capillary action before? This is actually what? This is intermolecular forces and
No,
intramolecular forces. Okay, acting together. That is why your meniscus. Are you familiar with the meniscus? Everyone, are you familiar with the meniscus?
no, sir.
Okay, if you're going to look at your um graduated cylinder, if you tried using that one, or your test tube, like you put some water there and you check on the level of water, you can see actually a half moon shape. Okay, you can see a half moon shape there. It is called meniscus. Okay, that is the meniscus. Now, this actually explains why your meniscus curve up in water and your meniscus in mercury curve down. Okay, and actually your capillary action, you can observe this one if you're going to have your experiment with like for example some plants. Like you put some coloring or food coloring on water and put the plant there, tendency is the coloring there will be absorbed by the plant. How? This is because of the capillary action, the cohesive and the adhesive forces. Okay. Hopefully we can do also some laboratories or some experiments with this capillary action. And this will clear up your mind how this happens. So for example this one. Okay. If you're going to look at it, the color is actually in the glass. How can this be possible that the color will be transferred to the leaves? This is because of capillary action. And this is against gravity, by the way. It is against gravity. Okay? That is because of cohesive and adhesive forces. Vaporizing or evaporation. Okay? Is read EM. EM. EM.
Vaporizing or evaporation. Evaporation or vaporization is the transformation of a liquid into a gas. Evaporation takes place at the surface of the liquid. The process occurs faster at boiling point. Boiling point temperature is the temperature at which the vapor pressure of the liquid is equal to the external pressure.
Okay. So vaporizing or evaporation. Okay. This is transformation of gas into liquid, or transforming liquid into gas, rather. Evaporation takes place in the surface of the liquid. Yes, of course. Again, we need to consider the boiling point. The boiling point, there are a lot of instances that the boiling point of water is not equal to other substances. Okay, like for example, the boiling point of mercury is not equal to the boiling point of water, at which the vapor pressure in the liquid is equal to the external pressure. So you are now transforming liquid into gas. Again, vaporizing, evaporation, this is transformation of liquid into gas. Okay? Evaporation and the boiling point, bubbles cannot form in evaporation, but in the vapor pressure, you can actually see some bubbles rising up. Solids. Let's move now to solids. Solids are incompressible, rigid, and compact. Okay? Please read, Rabi.
Incomprehensible, rigid, and compact. Solids are nearly incompressible, not compressible, or can be slightly compressed. Rigid because strong attractive forces hold the
Okay. Alright. So again, solids are rigid, incompressible, and compact. Okay? Because they're they held together with strong attractive forces. Again, they held together with strong attractive forces. They do not flow. Okay, solid particles do not flow. Please read EM, EM,
Sure.
EM.
Sure.
Please read do not flow.
Solid particles, in contrast to liquid particles, only vibrate at fixed positions. They do not slip and slide to fill the container. Hence, they do not flow. Two types of solid structures. Crystalline solids have defined shape. Their particles, atoms, molecules, or ions occur in highly ordered arrangement. Some crystalline solids can exist in various forms. These crystalline solids are called allotropes.
Okay, correct. Solid particles, in contrast to liquid particles, only vibrate in fixed position. Okay. There are two types of solid structures. You have crystalline solids, have defined shape. And I know that you know the crystalline solids. You will be enjoying seeing them. Their particles, atoms, molecules, ions occur in a highly ordered arrangement. Okay. These crystalline solids are called, some crystalline solids can exist in various forms. These are called allotrophs. Okay. Let's see some allotrophs. These are the bonding. Okay. We'll be discussing bonding in your higher years, metallic, covalent, and ionic. Okay. These are some allotrophs. Your birthstones. Okay. They are actually in various forms and they have fixed shape. Okay. The second one is if we have crystalline solid, we have also amorphous solids. Okay. Please read Rabi, amorphous solids. Rabi.
Amorphous solids are non-crystalline. Examples are charcoal, rubber, and glass. Amorphous carbon charcoal is produced by destructive distillation of wood. Another form of amorphous solid is carbon black, powdery soot formed from incomplete combustion of natural gas. Carbon black is used as a pigment in printing inks and in carbon paper, typewriting ribbons, photocopying machines, etc. If carbon black is heated to 800 to 1000 Celsius Fahrenheit, I know, degrees Fahrenheit, sorry, activated carbon is formed. It is highly porous like sponges or honeycombs. It has high absorptive property and is used in masks and water filters. It also helps remove colors and odors in some industrial process.
Okay. Amorphous solids are non-crystalline. Since it don't have form, it doesn't contain any form, and they're usually carbon. Charcoal are produced by destructive distillation. Yes, that's one of the amorphous solids. Glass, okay. Carbon black, soot, powdery soot. Are you familiar with the soot? When you say soot, in Bisaya, it's takuling. The one, the black one
Powder.
um in your kettle, those are the powdery soot. Okay, those are carbon black. Now, if you're these are formed in incomplete combustion of natural gas. Yes, these are used also meant for ink, carbon paper, ribbons. And if carbon black is heated from 800 to 1000 degrees Celsius, this carbon black will be transformed into activated carbon. And activated carbon has a lot of purpose, even in health. Activated carbon also absorbs absorbs odors, bad odors. It absorbs also uh, some destructive viruses. That's why they usually use carbon black or activated carbons in your mask. Have you seen some masks with activated carbon, activated charcoals? Okay. Actually, that's one of the use of those.
No, sir.
Question so far, we have the two forms of solids, the crystalline solids and the amorphous solids.
None, sir.
Okay, please read EM since Janine don't have a microphone.
Liquid crystals consist of individual molecules. These molecules are long enough cylindrical shape. This structure is such that it allows intermolecular attractions but inhibits crystalline packing. There are three different types of liquid crystal phases. Nematic phase. The molecules lie in the same direction, but their ends are not aligned. It is the least ordered kind of liquid crystal.
Okay. Liquid crystals. Have you seen the liquid crystals? It allows intermolecular attractions but inhibits crystalline packing. So it is not a crystalline solid. Still, it is under liquid crystals. It's different. Okay. Liquid crystals are in your the one in your LCD of your um, calculators, the old calculators. Those are liquid crystals. Okay. Liquid crystal display LCD. That is your LCD actually. Liquid crystal display. Okay. There are three different types of liquid crystal. Nematic. First is nematic. Okay. The molecules lie in the same direction, but their ends are not aligned. It is least ordered kind of liquid crystal. The second and the third one, please read, Rabi. Rabi, please read. Rabi, Rabi,
Ay, sorry, sir. I was muted. Cholesteric phase. The molecules are more ordered. It is similar in nematic arrangement. However, each layer is rotated in a fixed angle with respect to the next layer. It resembles a twisted nematic phase. Smectic phase. It is close to the solid phase. The liquid crystals are ordered in layers. Inside these layers, the liquid crystals normally float around freely between the layers.
the second one is the cholesteric or cholesteric phase. Okay, the cholesteric phase are more ordered. It's similar to nematic, but however, each layer is rotated at a fixed angle with respect to the next layer. So actually, there are some patterns. You can see it resembles a twisted nematic phase because the pattern, you can actually observe some pattern. Smectic phase, on the other hand, is close to solid phase. They're ordered in layers. Inside each layer, liquid crystals normally float. If you're going to look at it, this is actually how it looks like. Okay, pneumatic phase. You're going to look at pneumatic phase. That is the arrangement. The end is actually, if you're going to look at its end, it is not arranged properly. In smectic phase, if you're going to look at it, the there are some spaces in between, okay, that they can actually move, okay. Choleris- Cholesteric phase, you can see some patterns with respect to one another. Change in physical state, okay. We will be discussing this one by next meeting. I'll be I'll stop my shared screen. I think that will be all for today, class. Hopefully you learned something out of our discussion, and thank you for your time. Okay, please
Yes,
be
sir.
on time by my next meeting.
Okay,
We'll
sir.
be continuing the discussion with the change in physical state. Okay, physical change and chemical changes in a matter. I think that's all for today. Thank you for your participation. Have a nice day, everyone. Goodbye.